Well, good afternoon, everyone. Welcome on board. Today's discussion, airport design standards. A fancy way of asking or answering the question, is that airplane the right size for the given airport? It isn't always looks that make the determination. In fact, it never is how an airplane looks. Much more goes into it. So again, today's discussion for those interested, and thank you for your time. Airport design standards, a simple discussion of airport design standards, how they relate to a given aircraft size, among other characteristics. It's not just the size of the airplane that is considered, it is other aspects of the airplane. Some disclaimers, of course. I represent no one other than myself. I do not represent my employer. I do not represent the local airport, its management company, its resident airline, and my words, discussion, are not endorsed by anyone. Furthermore, I am not an airport planner. I am not an airport engineer. I do not have a degree in any of those subjects. So why might I be talking about this? Just as a heads up, I am merely a commercial pilot with 30 years experience flying, near 25 of them as a professional pilot. I'll kind of skip over my qualifications because they're not important. Let's just say I have experience in the world of aviation. I do have a paltry degree in business management. I've taken some side courses and maybe some core courses on these particular subjects, but my experience as a commercial pilot of many years, an instructor, and my involvement voluntarily and otherwise has afforded me some level of qualification, I humbly submit, to generalize this discussion and talk about the main issues. Again, I am not an airport planner, an engineer. I am not a delegate of the FAA, and I am not an expert on this subject, but I am well versed enough, in my humble opinion, to address some common concerns, and I address those concerns with my years of experience. This was the first airplane I flew as an airline pilot, first as a first officer, then a captain for the Continental Express network. ATR 42, 46 to 66 seat airplane. So again, that was my first job as a commercial, or what's called an air carrier pilot, flying out of Newark Liberty International Airport. I moved on a few years later to the Embraer 145, where again I served in this case as a captain. I've amassed about 13,000 hours in this airplane. And again, flying for Continental Express, United Express, and many of the places, of course, those airlines flew as a result of their network. I then, after that job, moved on to flying privately, flying the Citation Sovereign to basically wherever people wanted to go, who had the means to do so. So that was Citation Sovereign. That was a 9-passenger jet, obviously configured rather comfortably for a luxurious flight. The airplane itself had a 73-foot wingspan, I might add, which is an important consideration when we're talking about airport design standards. We will talk about wingspan and other factors that go into airport design standards, and I'm currently on the Embraer 190, 195 aircraft for an airline. Again, flies many places. It's a low-cost carrier, and we do actually have a base of operation, one of a few, in none other than our home state of Connecticut. So I'm currently a captain on this aircraft for a low-cost carrier. So, how big is too big? First, a visitor to Tweed. I wouldn't say frequent, but we've seen it a few times. Air Force 1 or 2, depending on who's on board. That's a Boeing 757. And a Boeing 757 clearly is a large airplane, large no matter the airport. One thing to consider in this discussion is something being large or small relative to what? Relative to the other types of aircraft and the regular types of visitors, if you will, to the airport. Visitors being airplanes, because an actual number is used to set a standard for airport design. And that number we'll reference many times is 500. That is a number used as a critical determinant in an airport setup, if you will, for certain kinds of aircraft. Obviously, a 757 is not an airplane we see on a regular basis, nor is the C-17. The C-17 usually comes when that 757 comes. And here are some basic numbers on a 757. Interestingly, the length of the airplane fuselage is similar to the length of the wingspan. They're in the neighborhood. I'll also say I'm using approximate numbers when we're talking airplanes because, frankly, there are many versions or variants of a given aircraft. And while it is intricately important in this discussion, overall, we're not making decisions today. I'm not in charge of the airport. So talking in general terms, ballpark terms, is going to be the mantra of the day. So a 757 is clearly a big airplane, not just by its dimensions, but by its weight. And that weight for that given airplane is 220,000 pounds. Something to keep in mind, a maximum certified weight of an airplane is just that. It does not mean that the airplane is always operating at that given weight. It means that it is certified to operate to that weight. So something very important right off the bat early in this discussion is the actual weight of the airplane at any given time. And that weight makes a determination in the aircraft performance, particularly from a runway standpoint. But it will be important when we talk about airport design standards as weight of the airplane, not a determining factor, but an important factor and one to consider, but again, not a mandatory factor when talking about airport design, airport facilities, infrastructure, if you will. So again, the point is you have a 757 airplane that weighs potentially 220,000 pounds. One might ask, isn't that too heavy for the airport? Isn't it too heavy for the runway or the taxiways? Well, needless to say, it was there and nothing bad happened, so that's one indication. But we'll verify that with actual data and literature that I'll share in a moment. The C-17, here are the dimensions: 169-foot wingspan, 174 feet long. It clearly is a bigger airplane than the 737. And the C-17 is certified, again, I'm just doing a general search, I'm not using the actual airplane flight manuals. It's certified to 585,000 pounds. Does that mean that's how much it weighed when it was at Tweed, for example? No, it doesn't. It's mission specific. It depends on what the airplane is carrying in terms of payload, passengers, cargo, and the large or lion's share of weight for an airplane is fuel. And if an airplane is doing a short flight as opposed to long flight, it is generally going to be carrying less fuel, and therefore it will weigh substantially less than its maximum certified takeoff weight. So purely because we see numbers that indicate a maximum authorized takeoff weight does not mean the airplane was over the weight of a given parameter. We don't know what the weight of the airplane was. The crew does. Things of that nature are known by the crew. Sometimes, and we'll talk about the circumstances, the airport operator will know about those things. But clearly, the C-17 and the 757 are not regular visitors to Tweed Airport. They fall below the standard that we're going to use, which is 500 operations. If an aircraft is determined to frequent an airport at 500 operations or more, that begins to set the standard by which the airport is built. So Tweed New Haven Airport essentially is not built to the standard of a 757. It is not built to the standard of a C-17, yet those aircraft landed safely and took off safely. Does not mean they operated with violations, if you will. It means the airport is suited for them with limited operations. Another way to also think about limited operations is it prevents the combination of those aircraft to be at the airport. So if you were to operate a half dozen C-17s from Tweed New Haven Airport, you would actually approach safety concerns. That not being the case, it was safe to do so. So I'm speaking in generalized terms. I'm not a crew member on either of those aircraft. They're also military, and so they have additional standards and procedures to follow. But that said, Tweed New Haven Airport is not a certified, if you will, or designed airport for those kinds of aircraft if they exceed 500 operations. One way to look at this issue is runway length is not the sole determinant. In fact, it's one of the lower priority ones for determining if an airplane is suitable for a given airport. That is to say, you can have a 10,000 foot long area to land an airplane in, but then the facilities built around that runway may not be suitable for a given airplane. So in this discussion, we're going to talk about two very important areas of the airport. Runway, which ends up being a very simple discussion, sans all the technical issues of aircraft performance, but the runway itself in terms of its dimensions and to a lesser degree its weight-bearing capacity is a fairly simple and straightforward standard that we'll look at. And very clearly, we're going to discover that Tweed New Haven Airport, in terms of runway length, runway width, and even weight-bearing capacity, is a suitable airport for the 737-700 and 800. We'll get into it in a moment when I speak about the dimensions. But actually more important than the runway, with the size of airplanes, and due to a number of factors, is taxiway. So the taxiways are the areas of pavement used to get to and from the runways, and parking areas. So taxiways link parking areas with runway areas, if you will, to keep it simple. So in my opinion, and this is just my opinion, but for purposes of this discussion, I think it's helpful to actually realize and recognize that taxiways and other areas of the airport could actually be more restrictive than a runway itself. Again, you can have a 6,000 foot runway and very limited infrastructure in terms of taxiways and parking areas, and therefore landing an airplane would be unwise, if you will, if not safe, if you didn't have the extra facilities to accommodate the airplane for maneuvering on the ground. So this is what we're actually getting at. Are these airplanes suitable for maneuvering on the ground at Tweed New Haven Airport? Again, the runway is going to actually be a fairly simple issue. Taxiways, simple, but a little more in-depth. I should say I have up a web page which I find very helpful. The website is sehinc.com. So again, this website, sehinc.com, and it talks about navigating the latest FAA airport design standards. 5 highlights airport officials need to know. And that's exactly our subject. And this document, or this web page, also references very important document, which we too will reference, the FAA's advisory circular, which is guidance in terms of how to comply with the standards the FAA sets forth, in this case, airport design. We're also going to talk about new guidelines as compared to older guidelines. And also I want to add another important factor in airport design standards is not just taxiways, not just runways, but the layout, the geometric layout, the angles of taxiways and runways reference to one another. I should tell you these are not general hindrances at Tweed, but they still are factors that are viewed and analyzed prior to an airplane serving the airport. So again, serving an airport with an airliner type aircraft is not just a matter of, is the runway long enough? Surely we look into that. Airlines do that, of course. There will be, of course, operational limitations, which we'll get into, but that's related to aircraft performance, not aircraft or airport design standards. Again, you then want to look at maneuverability issues for your aircraft at the given airport. And so it's not just the width of a taxiway, it's not just the obstacle-free areas, but it's also the angles of the taxiways, which is a way of saying what is the airport layout. Think about 90-degree angles, or acute angles, or obtuse angles, things of that nature. So this website, by the way, is very helpful to reinforce this discussion. Speaking of airport layout, here is one of many renditions of Tweed. There are also issues with this in terms of looking at various airport diagrams, publications as they're called. This, for example, is not a publication or a diagram that a pilot uses to maneuver around the airport. This diagram is an airport layout plan, and it is used by airport management, airport officials, planners, and engineers. But it also represents, essentially, what a pilot sees on his or her airport maps. Just the note that you could come across different maps, different layout presentations, but the basic picture remains. Of note, there's going to be different information, depends on who the audience is. So in general with this type of thing, you can assume this is what the airport looks like currently. It's what, well, actually not currently, this is a future rendition, but what you see for engineers is generally what pilots see for their documents, but often there are many differences. But again, I just wanted to point out in the discussion about the geometry of the airport. Clearly you see a runway, clearly you see taxiways. This is the runway, of course. And then you see, again, the geometry of the airport. That is the angles of the given taxiways reference one another. And again, this happens to be taken from the Tweed New Haven Airport Master Plan. It's a rendition of the airport layout, and something that's very important. The ALP, or airport layout, is approved and reviewed, of course, by the FAA itself, the Federal Aviation Administration. It is not something simply produced by the airport. It has to be approved by the FAA after the airport produces it, so that then the FAA in this case will review what will become what's called the critical aircraft for that airport. They have specialists, airport planners, people who specialize in exactly this area of expertise, and they will therefore approve or disapprove the airport layout for a given airport for a given critical aircraft. The critical aircraft, which we'll look at the exact definition in a moment, can simply be thought as the most demanding aircraft expected to exceed 500 operations at a given airport, that being 500 per year. Simply, yes, you can say it's the biggest airplane that you might see there, but not necessarily if we wanted to get technical. But overall, you can rest assured that in the case of the critical aircraft for Tweed, defined as 500 or more operations per year, we are absolutely honing in on the Boeing 737. So, this airport layout has been reviewed and approved by the FAA. A document of great importance is Advisory Circular 150/5017, Critical Aircraft and Regular Use Determination. This is exactly the area we just discussed, and the document that is given consideration by the FAA, as well as it explains the process, in part what we're going to talk about. So I will not reference much more than this document other than to say it can be found at faa.gov, and it is of great importance when one makes the statement, this airport was not meant to serve this size of aircraft. This is one of the guiding documents that answers that exact statement. Critical aircraft and regular use determination. An additional document of great importance and relevance that once again addresses the statement that airplane is too big for this airport, or that's the wrong airplane for the wrong runway, is addressed in document 150-5300, 13 Bravo, Airport Design. So again, this is the document that one would reference when making such statements or when asking such questions. And we'll ask questions. Is this airplane too big for this airport? This is where we find one of the many answers. So, getting on to definitions from these various documents, what is the purpose for making critical aircraft determinations? I'll paraphrase somewhat. It is an important aspect of airport planning and design for federally obligated airports. That means airports that receive money. It comes with a price. You follow our standards. Tweed is one of those airports. Critical aircraft determination sets dimensional requirements on an airport, such as the separation distance between taxiways and runways, and the size of certain areas protecting the safety of aircraft operations and passengers. An accurate critical aircraft determination helps to ensure the proper development of airport facilities and appropriate federal investments in airport facilities. I'll also add, it does not just promote development, but it promotes the maintaining of these airport facilities. An accurate critical aircraft determination matches aircraft operational area dimensions to the most demanding aircraft that regularly use the runways, taxiways, and apron areas. So, yes, runways important, taxiways are important, apron areas, and we're going to talk about the interrelationship between all of them. These are things reviewed and under the purview of the FAA. What is the definition of a critical aircraft and regular use? Most demanding aircraft type or grouping with similar characteristics that make regular use of the airport. Regular use is 500 annual operations. I'll spare you the rest of the technical mumbo jumbo in that, and then it just tells you that an operation is either a takeoff or landing. And when we talk about air traffic control operations, that's an important number. But for now, no need to explain touch and goes and things of that nature. So we're using 500 annual operations of the aircraft as the benchmark. Anything under than that, you could actually have an aircraft larger than is appropriate, for lack of better statement. And you're protected by common sense, of course, operational procedures of the crew, but simply you're statistically avoiding a range of circumstances that 500 or more would actually protect you from. So a way to think about that is combinations of aircraft. How many aircraft of a critical size could you have on the airport and still be within safety margins? If you had an A380 land at Tweed New Haven Airport, it would actually, besides being very attention-getting, would be okay. because it happens very infrequently. And while the airport does not meet the standards for that airplane on a regular basis, it does in many other ways, and there are permissions granted for such things. And that's the case of the 757s and the C-17s. But in this case, we're talking about regular use by a particular aircraft, and clearly 737s and a Velo meet that benchmark. Does the FAA's airport or Office of Airports approve the critical aircraft determination? Well, to answer this question is almost to end the discussion. We have a certain component of the public making statements that are unfounded, untrue, unsubstantiated, and frankly malicious and endanger the public, when in fact the regulating authority, the FAA, not saying they're perfect, by the way, but they are the ones in charge. They're in charge of this. They approve by what I'm about to read. The answer is yes. ARP, that's a designation for the FAA's airport office, typically the ADO, again, another abbreviation for an FAA person or authority, will approve both the existing and future critical aircraft determination for an airport as submitted by the airport sponsor. During the planning process, this is normally done during the FAA's review of the forecast and documented in the forecast approval letter. I'll not read the rest of this, but this is a very easy way of saying this isn't my word, this isn't the word of others, this is the word of the FAA. And while they are imperfect, they're the ones in charge, they're the ones with the authority and the expert knowledge to make these determinations. And for this airport, Tweed New Haven Airport, to be functioning and regularly handling 737, 700, and 800 aircraft, this, beyond a shadow of a doubt, says everything we're going to talk about has already been approved by the FAA, and it really isn't necessary. But in the interest of communicating, sharing information, we're going to. Can different aircraft represent the critical aircraft for separate elements of airport design? What that's asking basically is, or addressing, certain parts of every airport may in fact not be suitable for that given aircraft. And I'll reference this a couple of times, if not in the very near future, but the reality is almost every airport has a variation of limitations or limitations imposed. And those limitations are imposed because, in fact, certain segments of the airport are not sufficient for a given aircraft. So I'll say that again, that's pretty impactful. Number one, this applies to countless airports, airports that we all fly in and out of on a regular basis. Certain aspects of those airports are not suitable for the critical aircraft. Pick any airline hub, for example, just randomly, and I'm not using exact example, I'm using general example. Take Charlotte Douglas Airport, home to now American Airlines. Obviously, the critical aircraft is going to be something bigger than a 737. It may, in fact, be the A330 series or 350 or 767 aircraft. And in fact, without looking at the proper literature, you may find, it would not be a surprise, that certain areas of that airport have restrictions of use for the biggest airplane. And I'll talk specifically about Tweed in a little bit about that very issue. That is not rare. It is common. And as to why it is a subject for another discussion. But it's common, it's known, and it's accommodated in proper amended procedures and other ways of doing business, if you will. So that is a very broad discussion stating that certain elements of an airport may in fact not be suitable for a given aircraft, and there are ways to address that. Speaking of, The next question, again, this is the FAA literature itself. For them to be asking these questions in a generalized document, not specific to Tweed, but appropriate, must mean there are other conditions throughout the country that exist just as they do at Tweed. Should all airport facilities be designated to meet the needs of the critical aircraft? Not necessarily. Cost-effective capital improvements are designed for the specific aircraft that use a particular portion of the airport. Therefore, it is appropriate for separate airside elements to have different critical aircraft determinations. Design taxiways, taxi lanes, and facility separations for the most demanding airplane design group using that particular area. I'm not going to read what they have left. I'll tell you. The east side of Tweed New Haven Airport, for example, has components, this particularly the east ramp and what's called a taxi lane. There are limitations, though not many, and in fact you've actually seen 737s over there, but just by example, that side of the airport is not necessarily required to meet the critical design standards for a given aircraft. Does it? Yes, but with some limitations. So there's always a catch, there's always a caveat. It's a way of saying being careful if you wanted to be general about it, but there are issues with aircraft movement under their own power versus being towed, etc. But suffice it to say, an entire airport does not actually have to meet the standards for the critical aircraft. I'll say that again. The entirety of a given airport does not necessarily have to meet all the design standards for the critical aircraft. That's not my words, that's the words of the FAA. Does it mean that that's necessarily the ultimate goal or going to persist? No, but it means exactly what I stated. Here's another important one, question 3.9, and we'll get into this element. Should a critical aircraft determination be made for pavement strength design? Very simply, some in the airport opposition community tout runway weight-bearing capacity, and I'll get into that discussion quite a bit in depth, but the simple answer is no. The pavement standards don't have to meet the criteria for a critical aircraft. The methodology for designing pavements is different. Refer to Advisory Circular such and such, which is entitled Airport Pavement Design and Evaluation. FAA pavement design considers the damage to the pavement from each individual aircraft in the traffic mixture. The final pavement thickness is based on the cumulative damage of all aircraft. The important takeaway from this is weight-bearing limitation not being something one should ignore. One should absolutely take it into consideration, but it is not a glaring safety oversight, very simply. I'm going to show you numbers and parameters that show Tweed New Haven Airport meets the standards for the given aircraft. I'll explain some technical details that I've kind of alluded to, but the bottom line is it does meet the standards, and I'll explain why, and I'll show you the numbers in a moment. But if anyone were interested, the FAA, and I'll show you another document in a moment, its own literature says that weight-bearing capacity of a runway is actually not a limitation on the airport when determining critical aircraft. We're almost done with these. How is the critical aircraft determination applied to runway length? Evaluate each runway separately at an airport. Choose the single aircraft or grouping of aircraft with similar operational requirements that have the longest runway length requirement that makes, again, regular use of the runway. In some cases, the critical aircraft for runway length may be different from the critical aircraft that establishes the most demanding runway design code for the runway. Runway performance is a subject unto itself. I'll touch on it as I have in the past, but it is one that deserves its own subject. But I'll say at this point, runway performance is based on a number of factors for an airplane. It is not a static number, and I'll get more in depth in that in a moment. So runway length is not a determinant. Aircraft performance is. Aircraft performance varies throughout different parameters and different conditions, and an airplane could operate very simply from a shorter runway depending on its mission as opposed to a different day when it is going to do a longer mission, if you will. Shorter missions typically equate to less fuel and less weight, whereas longer obviously equal differently, and therefore the parameters of aircraft performance are different. There's no static number, essentially, past or below a certain point where it is unilaterally acceptable. That is to say, you could operate a 767 from a 6,000-foot runway depending on the mission and depending on the conditions in which it's operating. So you cannot use a runway length as a static number, as many airport opponents like to do. And I'll show you why, because they make performance charts for that very reason. The airport layout plan. In the words of the FAA itself, an ALP is a graphic representation of existing facilities and proposed development plans for an airport. Airports that receive certain types of federal assistance accept a grant assurance that obligates them to maintain the current ALP. This tells you that this is a very important component to the particular airport. This said, I'll just see if there's anything of pertinence there. Then addressing non-standard airport conditions. I'm going to take a moment, let you look that over. Leave it here. You see everything that I thought was pertinent. This basically allows time to comply and circumstances if compliance is not appropriate or could occur. But I'll leave it at that for a moment and let you just read this. Again, I'll leave this so that you can read yourself. This is the actual literature of the FAA. Feel free to pause this, of course, if you like, if I move too quickly. So I have RSA dimensions, OFZ dimensions, approach or departure surface dimensions, and then stopways and clearways. Again, this pertains to the slides we just read, but it allows modifications to the standards in the object-free areas is the way we can generally refer to these areas. So again, an object-free area you could also think of as a buffer area adjacent to the surface the aircraft is using, that being a runway or a taxiway. We're almost done with the dry definitions, I promise. What we're going to get into is aircraft approach category and airplane design group, and we've already talked about the airport layout plan, or the ALP, but in this case we're going to hone in on the AAC and the ADG. Verbatim, the ADG, aircraft or airplane design group, is a classification of aircraft based on wingspan and tail height. I'll leave it at that. And aircraft approach category, this is the speed at which an airplane performs its landing approach when it's configured for landing. And that's going to come into play in this case here. Take my word for it. I'm experienced, authorized, and qualified to tell you that a 737, or the aircraft type that I fly, we utilize category C. So we're making our approach speeds between 121 and 141 knots. Those are typical speeds. Sometimes we might actually be in a different category based on certain conditions, but I'll spare you that discussion. 99% of the time, the 737, the Embraer 190, that category of airplane, an A319, are what's considered approach category C, C as in Charlie. And then further, we are all considered in a happy family of airplane design group 3. I'm not so concerned with tail height. We'll leave that out of the discussion. But the wingspan is 79 to less than 118 feet. And I'm going to show you the specifications, the general numbers for the airplanes. Therefore, when it comes to the runway design group, we consider airplane approach category, airplane design group in order to get a runway design code, an RDC. So for now, we are C3. I'll just add, and you can take my word for it, they add a 4-digit number which pertains to visibility. I'm going to spare us right now. I'll show you on an approach chart where I'm getting that number. But as I said, the RDC, the runway design code, is a 3-component code sharing the AAC, ADG, and the approach visibility minimums established the design characteristics for a particular runway. So I'm going to show you an actual chart that we use to land in poor weather conditions at Tweed that shows we are appropriate for the given aircraft. And again, don't worry about the 1200 or that number pertains to visibility. And just like magic, there's the chart. If you focus on one area, I'm not going to teach you how to read this chart, it's not necessary. We have category A, B, C, and D. That simply is a way of saying if you're flying an airplane and you're flying at this speed, which the pilots, we know this is our aircraft, this is what we're trained for, this is what we have manuals for, we are category C. And the way this chart works, very simply, since it's uniformly across from A through D, A being the slowest airplane, D being the fastest airplane, that means this approach and the other approach that Tweed has coming in from the north will be the same way. It is approved for all categories of aircraft, any speed. In fact, if you wanted to fly a MiG-29 on this approach, you would be allowed to based on these minimums. So, looking at the instrument landing system for runway 2 as it applies to approach speed, which also it is factored in visibility and wingspan, but I'm keeping that element out right now. Very simply, we have published minimums for a given approach category, which again references runway design code and the AAC. And then again, this is listed on the ALP, the airport layout plan, and it is a fact that Tweed is listed as a C3. C3, and we're going to look at the wingspan in a minute. But I know the 737 approach speeds. I know the approach speeds on the own airplane that I fly. This is fact. This is not conjecture. This is not my opinion. I am legally allowed to conduct the approach to this runway based on what I just told you. And of course, I know the wingspan of my airplane, which this is not. This first references 737-300. Came into New Haven, United Airlines. 737-500, United Airlines. They operated those two models from Tweed. We have the 737-700. Honing in, interestingly, the wingspan of the airplane is 117 feet, 5 inches. Magically, that fits in the 118-foot limitation. And these are also the wingleted versions. So again, this is a model 700W or BBJ. Take my word for it. We're not talking huge difference, if there is even a difference. This may not be the exact version. That said, it's a 737-700, and it's a great approximation. I may come back to this, but if you can memorize these points or these dimensions, because they are important for a later discussion. But for now, remember 118 feet is our limit, and we're at 117 feet 5 inches for the 700. And interestingly, the 737-800 has the same wingspan. So by definition, the words and literature of the FAA itself, first, you can take my word on the approach category. I don't have a manual with me right now. I have my own experience doing this, that our approach categories are Category C. We fly a range of speeds based on weight and other conditions, and the wingspan is always the same. So by that definition, the AAC and ADG, the Boeing 737 is a C3 category aircraft, and interestingly, that's already been approved by the FAA on the airport layout plan. Take a deep breath. That was the easy one. The second easy one is aircraft firefighting indexing. Indexing is a way to refer to the number of fire apparatus or rescue apparatus at an airport in addition to other requirements. This is taken from CFR 14, Part 139, and I'm responding once again, not just to the malevolent, malicious, and misinformation spread by certain individuals that Tweed has no fire protection, but this is a measure indicating the appropriateness of the 737-7 and 800 airplane from serving Tweed New Haven Airport. It's allowed because Tweed New Haven Airport is an Index B and is capable of Index C. I'll let you look at this chart. Of interest is the aircraft length. The 737-700 is between 90 and 126 feet. The 800 is a little bit more than 126 feet. In fact, it's 9 inches longer. The determination is not just the length of the fuselage, but the number of operations, average daily operations. I'm not going to belabor this point, but very simply, the number of operations per day and the average then becomes the determinant for the index. Tweed New Haven Airport currently meets Index B, and they are flexible, like many airports are, to meet Index C with proper notification. It's a simple phone call, if you will, from the operations staff of the airline to the staff of the airport. Not going to get into that process because it's none of my business, nor is it my area of expertise, but I know that it happens, and I know the literature that indicates the index for a given airport, so that I know that my own aircraft is appropriate for a given airport. My aircraft and the 737 would not be appropriate if the airport met Index A. They have to meet Index B, and then the criteria for Index B would be the number of departures of the larger airplane, the average number. So if you notice, the 737-800 continues to come into Tweed. They don't meet Index C currently because the average number of daily departures is less than 5. When it goes above 5, they will meet Index C, and that will be the end of that. So Tweed is either an Index B or C airport. I'll let you look at this table and dwell on that issue because it's rather simple. This is published data. This is not make-believe. For now, I'm not showing you the published literature that pertains specifically to Tweed, which you can find in the Airport Master Record. 5010 is the document. You could also find it in the pilot publication, which this is an excerpt from, which is the chart supplement. Tweed New Haven Airport is indicated to pilots as Index B with the capability of Index C that meets the fuselage length requirements as well as the average number of daily departures, and therefore from a firefighting crash rescue index, Tweed New Haven Airport is the right airplane or the right airport for the right aircraft. I'll say that again. Uncontested reality, this is approved. There would be major trouble. The airport meets Index B, which meets the standards of the 737-700 and 800. And then if they up the number of 500 or 800 departures to average 5 or more, they'll be able to meet Category C or Index C. So this is the right airplane for the right runway based on Aircraft Rescue Firefighting Index. So we've now addressed in a very casual setting 2 reasons the airport is the right airplane, or the airport is the right airport for the right airplane. The 737, 800, and 700 are a good match, or a legal match if you want to get technical. I'll very quickly talk about aircraft performance. We have some prominent airport protesters spewing numbers. It's absolutely misleading, misguided, malevolent, malicious, misinformed. Need I go on? This is a person that grasps very little or grasps quite a bit and chooses not to share the big picture. This is what I do. This is what pilots do, dispatchers do for a living. This is what aircraft manufacturers specialize in: charts, performance, numbers. It is not as simple as the airport opposition crowd makes it out to be. I'm not going to belabor the point of aircraft performance at this point. Can do that in a separate area again. But very simply, aircraft performance is a charted phenomena, if you will, that is impacted by numerous factors: weight, weather, pressure, altitude, etc., things we won't talk about, thankfully, today, that makes a static number not the way you refer to aircraft performance. A 737, my airplane, may in fact require, under certain conditions, 12,000 feet of runway. But those are under very unique or very specific conditions that in fact are pretty rare. They will deal with slippery field conditions, high weights, high temperatures, high pressure altitudes. These are things that are not addressed by these individuals because they are willfully misleading people and, quite frankly, endangering public safety by making these statements. They're taking these numbers completely out of context, and I would argue deliberately so, because they are smart. They are smart enough to know what they are doing, which is misleading people and stating very static numbers, snapshot numbers, without the proper explanation. If anyone is ever interested, I'd be happy to explain aircraft performance. My life depends on it, and so too that of the passengers. This is a landing performance chart. Again, they make charts for a reason. As you can see, the numbers vary. There's a range of possibilities here. It is not just a number. This is taken from the Airport Master Plan. This shows, in very generalized terms, runway requirements for select airplanes at the time determined to be the critical. And in this case, you can consider the A319, 20, and even the 220 to be similar critical aircraft to the 737. And you notice there's a range of numbers. I'm not going to get too in depth with that, except to say it exactly proves my point that aircraft performance, when it comes to runway length required, varies throughout a range of conditions. Let's see if I can repeat that again for impact and importance. Aircraft performance, runway, takeoff, and landing is not a static number. It is a number that varies across a range of circumstances to include weather, weight, altitude of the airport, things that are necessary to be charted and computerized now, because we use obviously a lot of computers as opposed to the manual charts. But regardless, aircraft performance is a non-static number, and it is in fact a characteristic of an airplane that varies across numerous conditions. Airport Facility Directory Legend. This is, again, is still part of the chart supplement. It is a publication meant for pilots, but it brings up an interesting point on the third issue with regards to Tweed New Haven Airport and the wrong runway and the wrong airplane, and that is runway weight bearing capacity. Remember, and this will fortify the statement, runway weight bearing capacity is not viewed by the FAA as a necessary limitation or an absolute limitation to use of an airport. And again, this is exemplified in the statement. We'll join runway strength data shown in this publication is derived from available information and is a realistic estimate of capability at an average level of activity. It is not intended as a maximum allowable weight or as an operating limitation. Many airport pavements are capable of supporting limited operations with gross weights in excess of the published figures. Permissible operating weights, insofar as runway strengths are concerned, are a matter of agreement between the owner and user. I'll leave the rest of the reading to you, and I'll explain in greater detail what we're going to be looking at in a moment. The overarching issue here is runway weight bearing capacity is actually not considered a limitation. Should it be considered? Yes, absolutely, and it is. But if you recall, remember, 2 airplanes come into Tweed. One of them is certified to 585,000 pounds. I don't have to look at charts to know that exceeds the weight-bearing capacity published that we're going to look at for Tweed New Haven Airport. But we're still here today, and it's because of this literature and what we'll discuss in a moment. This is just a table for wheel configuration. Don't want to get too in-depth with that, but we have 2-wheel configurations, 4-wheel configurations. The 737 is a 2-wheel tandem wheel configuration, which is considered, as I said, D when we look at the chart supplement for Tweed Airport. But there are other considerations, and we're going to look at 2S. Very simply, Tweed is certified to 160,000 pounds for dual type landing gear and 175,000 pounds for 2 single wheels in tandem like a C-130. Now, I don't know if I actually have that in this presentation, but you can take my word, those are the published numbers. So we're using 160,000 and 175,000 for the wheel configuration of a given airplane. So Tweed Airport is actually certified to 175,000 pounds, depending on the wheel configuration, or 160,000, neither of which is an actual limitation based on the literature. But we have one other criteria that is published and therefore certified, and we meet without a shadow of a doubt, and it doesn't need a discussion other than to say the numbers and leave it at that. and that's called the pavement classification number. The pavement classification number at Tweed is 57 for the record. This can be again found in the airport master record 5010 or in the chart supplement. And that PCN is a pavement classification number. It's an engineering assessment of the runway. It deals with, very simply, without getting into an area that I'm not an expert on by any means, but can understand in general terms, it deals with the pavement flexibility and it deals with the pavement subgrade. So the PCN is an additional measure of runway weight-bearing capacity, strength, if you will, that considers runway rigidity or the pavement rigidity, whether it's flexible or not, and the terms of or kinds of asphalt that is used, bituminous, for example, and then it's subgrade. They're very fancy ways of saying it's how the runway's constructed. It's not just a simple piece of pavement. It matters the texture, the kind of pavement, and the subgrade. PCN for Tweed Airport is 57. And I have the second best document to the 5010 form and the chart supplement, and that's the capacity. It's the airport master plan, and it's the catalog of the facilities. It says runway 220 has a pavement classification number of 57, F for flexible, C is the subgrade, X and T are not relevant to this discussion. I'll leave out. It has to deal with tire pressure, not of interest to us essentially. The PCN includes a numerical value of 57, which correlates to an allowable aircraft classification number, or ACN, F for flexible or bituminous asphalt, C for subgrade strength category, HVN subgrade strength is low, and X for an allowable tire pressure, etc. So, as I said, the 5010 form talks about the sufficiency of Tweed in terms of this, well, in this case, pavement condition. Very simply, airports have airport maintenance and pavement maintenance, and that's a whole nother discussion we're not going to address today. But interestingly, I have a table from ICAO, International Civil Aviation Organization, which the FAA, you'd be happy to know, adopts as a guiding document in this particular area. And I have the table, and I have the pavement subgrade and flexible pavement circled. 51 for 737-800, 900s, and BBJ. Now, if we were in court, ladies and gentlemen, maybe I would have to get a more specific document. But since opponents of the airport never seem to produce documentation, and those who do seem to leave out certain documents, here is a reference point. 51 is lower than 57, meaning the PCN, the pavement classification number, not just the weight-bearing capacity, is sufficient to make this airplane the right airplane for the right runway. So it isn't my word, it's the literature that supports. Very quickly, and as we finally and maybe mercifully come to the tail end of this presentation, what I have is a table with a range of operating weights for 737, depending on the version. Do you have to remember them? Absolutely not. I don't. That said, in addition to all of this that I just stated, to include weight-bearing capacity, 160,000 pounds, is not a limitation for the airport and the kind of airplane that it serves. The pavement classification number well meets the standard as published by ICAO for the 737-800 airplane. In addition, as I said, these airplanes are not necessarily operating at their maximum weight for a range of reasons. It depends on the mission. Where are they going? How much fuel are they required to carry, which is different on the same flight, possibly every day, because of other factors outside this discussion. These are issues that pilots and dispatchers deal with on a regular basis. And again, that's to say you fly from New Haven to Palm Beach, and one day the fuel required is one amount, and the next day it is another. Therefore, along with the limitations of the runway length and the performance issues, these airplanes are not even operating at the maximum weight of the particular airplane. So that's why I said earlier on, you can have an airplane that weighs 500,000 pounds or is certified. It does not mean it's operating at that weight. It may be operating at a very light weight. That is further why aircraft performance is a variable factor. So very simply, these are some tables with the given weights. If you can notice, some of the 737-800 models in general terms are under the 160,000 pound limit. So I would argue it's even necessary to find out the specific models of which, in this case, Avelo Airlines may be operating different versions of the 800 model and 700 model. It's very detailed. But generally speaking, these are the numbers we're working with. And this is a throwback to yesteryear with the older 737-300 aircraft. And again, you can see it ranges from 125,000 to 140,000 pounds. 737-500, same issue, from as low as 116 to 136.5. Depends on many factors as the airplane is built. We're almost done, everyone. That's what's good about the pause button. I would maybe, since we're an hour into this, you have the luxury of the pause button. I do not. So I'm going to continue onward. We've talked about the runway. We've talked about the approach category. We've talked about visibility to a lesser degree. We've talked about crash, fire, rescue. Now we're going to talk about, great, you've landed the airplane. What about being able to operate it? Some might think there was an incident where an aircraft had a taxiway excursion. That might be an indicator to some that the airplane is too big for the airport. Well, we're going to look into exact numbers that dictate otherwise. All of what I'm going to share with you is listed as followed, and I just realized this is from previous, but this is a good review. We have aircraft approach category, airplane design group, and the visibility minimums. These are what go into the runway design code, or RDC, as a review. So, taxiways, this is what I wanted to get at. Is that airplane too big for the taxiways? Well, the very simple answer is no, and we're going to see why. But what these pictures and diagrams show are not specific numbers, but things that are considered. You have an aircraft taxiing on a taxiway. It is normal, it is acceptable, it is common for the wings of an aircraft to extend beyond the width of a taxiway. That is not a violation, that is not an oddity, and it would frankly be impossible to build many airports if that were not the norm. So first of all, it is normal for an airplane wingspan to exceed the width of a taxiway. 100%. Everyone in the airport engineering world and planning will tell you that. They make object-free areas. What they're going to be concerned about is not necessarily just the width of the taxiway, but the areas adjacent to these buffers. Are they clear? Additionally, when considering the width of a taxiway as appropriate or not, it is the width between the main landing gear, one another, and the distance between the nose landing gear and the main landing gear that are considered. we have issues of maneuverability with the aircraft, and so standards have to be met in that way. But those are the considerations in reality that factor in. It's not because the airplane's wings extend past the runway edges that it indicates inappropriateness. There are other factors that are considered. So those first factors are object-free areas, which we'll look at. They're buffer zones at the edge of the taxiway. So obviously you don't want to have structures, although you are allowed certain structures in these buffer areas, but they have to meet their own standards. Those buffer areas have to be cleared. The width of the taxiway is important, but what's important, and specifically the number, and we'll use a round number, the distance between main landing gear on a 737 category airplane is generally 20 feet. And I will show you in a moment, every single taxiway at Tweed is 50 feet or greater. 50 feet is the standard for most taxiways, whereas many of them, even at Tweed, are greater than 50 feet. No taxiway at Tweed is less than 50 feet wide. Some of them are close to 100 feet wide, and we'll see in a moment. So the width of the taxiway, when it considers the main landing gear distance, one wheelbase to the other, is appropriate, and we'll see shortly. Then there are issues with parallel taxiways and wingtip clearances. Tweed New Haven Airport has no configurations such as what you see here, so we can kind of move past this, but it is an area that is considered when not only constructing taxiways, but when you want to have certain kinds of aircraft operating. The whole point being, if you have an aircraft with a larger wingspan, you want to maintain a certain distance from wingtip to wingtip, and they'll go out there and they'll measure it. And if it comes to being that an airplane has a very large wingspan, that airplane will either be restricted from that taxiway or maybe from the entire airport, but it depends. And so this, again, when it comes to taxiways, becomes an issue. Countless times, I can tell you hundreds of airports that I've been to that have notations to pilots that state if your wingspan is greater than a particular width, you are not permitted to use the taxiway. These are known, accepted issues, operational limitations, along with their attendant amended procedures to accommodate these issues at airports all across this country. These are things that pilots and air traffic controllers and airport managers and operations personnel not only know, but they're the ones who actually set the restrictions in place because somebody has reviewed these various possibilities and set forth the restriction. That entity would be the FAA. Then you have areas where you have parking areas, for example, and an airplane taxiing on the ramp behind aircraft that are parked. So again, you want to assure proper clearance. So that's where wingspan would be a consideration. So wingspan is a consideration with taxiway design and the designation of a group, but that doesn't mean that the wingspan has to be less than or equal to the width of the taxiway. This is a project recently completed. This is right off the FAA website. And basically what you can see is the new taxiway was offset to meet a new design standard put out by the FAA. I'll reference that shortly, and it'll be a further discussion in the future. But that said, I just wanted to show you this happens to be Taxiway Alpha. This is Robinson Aviation. This is the control tower. This is the west side where the passenger terminal currently is located. But this taxiway is a new taxiway or relocated taxiway that is now 400 feet from the runway. We'll reference that. These are other taxiways at Tweed, and I'm going to show you a description of these taxiways in a moment. This is Bravo Taxiway, Echo, and Juliet. This is going to be the area for the proposed terminal. But something I want to emphasize right here. The width of the runway at Tweed New Haven Airport is 150 feet. First of all, the wingspan of the 737 is 118 feet approximately, a little bit less. That means the width of the entire wingspan fits within the confines of the runway. Furthermore, these taxiways here are approximately 50 feet. So you will have situations where, of course, wingspan of many aircraft go past the width of that taxiway. That's allowed, that's acceptable. And as long as the area is clear of objects, of obstructions, to include other airplanes, then this taxiway could be certified to a certain category. What that's basically saying is, as long as aircraft are maintaining centerline on taxiway and flying over the runway or on the centerline, their wingtips could never hit. Now that's with the category of airplanes that we currently have. If I were to use 200 feet and use two airplanes, one on the runway and one on the taxiway, you might have some margins that were not met or that were too close. But we're not dealing with that. First of all, I know of no airplane with a 200-foot wingspan, and if it were coming to Tweed, it would certainly be under emergency circumstances and not regular. So with wingspans of less than 118 feet, we're never going to have a situation where the wingtips will touch one another, of course, because again, remember, for general purposes, the wingspan of the airplane is within the confines of this runway. This runway is 150 feet wide, so the entire span of the 737 is within that runway width. Here we have a table from the airport master plan, which is simply a regurgitation of the advisory circular. We'll focus our area on aircraft design group 3. The taxiway safety area has to be 118 feet. The object-free area has to be 186 feet. And the runway taxiway separation has to be 400. Then taxiway width, 50 feet, and the shoulder width has to be 20 feet. So a shoulder, by the way, could be actually another paved area, not approved for use, but just a paved area. Or it could be a grass area, and it can be considered within the object-free area. So what this basically means is with a taxiway of 50 feet wide, you have to have an area of 186 feet free of objects, and we do. The 400 feet is something we have to talk about a little bit because in certain circumstances we don't meet that standard, and that's why I showed you earlier why the airports are permitted, which what you might call non-compliance with the new safety standard. The original safety standard was 275 feet. We meet that. The new standard is 400 feet. Not in all cases, we do not meet that in certain portions of the airport. As a result, the airport may impose limitations on combinations of aircraft at any given time. That would, again, not be uncommon. That happens at other airports. And I'm not saying it happens at Tweed because the situation is variable, which we'll talk about. This, again, these are descriptions from the airport master plan. I have the areas of interest. Taxiway Alpha is 50 feet wide. I just showed you Taxiway Alpha. This no longer applies because it's now been rebuilt. So it is 400 feet, most of it. They have to do one other phase. Taxiway Alpha is 400 feet from runway 220 and meets the design standard the latest one set forth by the FAA. Taxiway Bravo, which is this taxiway, obviously you can see it's angular in nature, and therefore its distance from the runway is variable. And it varies, as listed by the Airport Master Plan, from anywhere from 470 to 275 feet from the runway center line, which, as it says, does not meet ADG, Aircraft Design Group 3, runway taxiway separation standards of 400 feet. But again, in some areas it exceeds, and in some areas it does not. Then it says from approximately taxiway Echo South, which is here, it's less than 400 feet. So that's where the variation is. This is where it's important to note it does not mean impending disaster. It does not mean we're operating in violation. It means we've not met the new safety standard imposed by the FAA, which could have been as recently as about 5 years ago. The FAA grants, this is why I started off with documentation that has literature supporting the compliance process and the reasons why an airport may not be able to comply. The FAA does not just change standards overnight and then render other airports or all airports dysfunctional and shut them down. It allows time and circumstances to amend the airport or to modify the airport to meet that, but that doesn't always happen, and there are reasons why. So Taxiway Bravo does not meet ADG 3 criteria because it varies in distance from 470 to 275 feet separation from the runway. This again does not mean that airplanes are going to hit one another wingtip to wingtip. It means the standard that now has been imposed is not met. The 275-foot requirement is met, and as I said, the wingspan of a 737 is fully encompassed in the runway width. So therefore, as long as the airplane is on center line, they will not hit, and even if there's room for variation to that. Namely, if the airplane is off the center line of the runway, there is still assurance that it will not hit another airplane wingtip to wingtip. That's a big subject, that's a big idea that may take some time to digest and require further explanation, but very simply, that distance is from 275 to 400 feet. Then Taxiway Charlie is 50 feet wide. It doesn't need to reference the 400 feet because it's not parallel to anything. Taxiway Delta is 50 feet wide. Taxiway Echo is 80 feet wide. Taxiway Foxtrot from 50 to 90 feet. Taxiway Juliet, 75 feet. Taxiway Hotel is permanently closed. Taxiway Gulf is not a taxiway used by Avelo jets. It's on the east ramp, and it will not be used when the new terminal, if it is built. But that said, it's still 50 feet wide. These particular taxiways do not need to meet the 400-foot separation standard as they are not parallel taxiways to the runway. So I'll say that again, and that's why I'm going fairly quickly over these points. These taxiways, Delta, Echo, Foxtrot, Gulf, and Juliet, for a range of reasons, primarily being they are non-parallel taxiways to the runway, do not apply the 400-foot separation standard. As far as width goes, and as far as object-free areas, shoulders, buffers, if you will, they meet Aircraft Design or Taxiway Design, TDG, Group 3. That is a random out of place chart. This is a reminder that 500 operations is the benchmark. And this is a refresher of the table that was taken and shown in the airport master plan. We're category 3 or TDG 3. I'll also say the website that I referenced very early in this presentation has, I believe, the most current standards, because they've even changed some of what might be published here. They've actually made them less restrictive, and there's logic why. But if you reference the website that I referenced early on in this presentation, it gives you what I believe to be the best and most recent standards being applied that may be slightly different from these numbers here. Again, here's a table. You can pause this. We are Aircraft Design Group 3. These are basically different combinations of airport surfaces in relation to one another. So again, that's a way of saying a taxiway or runway's proximity to other features of the airport, such as other taxiways and runways. So this applies. How far is a taxiway from another taxiway? How far is a taxiway from a runway? How far is a taxiway from a taxi lane, etc. Here's just a rough, non-scientific measurement of what I'm trying to talk about. And again, imagine an airplane, 120-foot wingspan, well within the confines of the runway, could never hit the wing of an airplane. Just because the wings go over the taxiway edge does not mean it's an inappropriate taxiway. And in fact, most taxiways, you will find that to be the case. This is taxiway Delta, for example. You essentially could never have the wingtip of an airplane, a 737, which would clearly be over the edge, come into contact with another airplane of same size on the runway. It's essentially guaranteed. That is the design standard upheld by this separation. So again, you have the entirety of this airplane, the entire footprint within the width of the runway. It is a physical impossibility for it to come into contact with another airplane. But those are indeed factors and considerations given in an airport when it comes to critical aircraft classification. They, in fact, are looking at these very issues. That is what airport engineers and airport planners are for. That is what survey teams are for. This is not about a rogue statement made by certain individuals with no substance whatsoever, no literature to back it up. Pure mythology promulgated by bias. The airport is not perfect. No airport is. That's a whole nother subject. Hopefully by now you've made it through this presentation with probably several pauses, I hope, for your well-being and cups of coffee. But hopefully this addressed the blatant disregard for factual information at the hands of certain people, which is not a constructive thing when talking about an airport. An airport's future development, it is very critical that we talk about things correctly, appropriately, factually, and non-sensationally, if not incredibly mind-numbingly boring at times. But these are the standards, these are the measures, literally and figuratively, that go into critical aircraft determination for an airport design standard. Again, in closing, thank you for your time. I'm humbled to be able to speak to you, humbled that you would be interested in my input. My input is commentary. My input leans towards fact, I hope is primarily fact, but again, I'm not an expert. I'm not an airport engineer in closing. I'm not an airport planner. I am not an airport manager. I am not yet an airport certified employee, although I'm working on that. Don't let that secret out, everyone. But that said, as pilots are and should be familiar, I am familiar with the standards. I know where to find the resources, which I illustrated in this presentation for you, for your benefit, for further questions, for further analysis. But the simple fact is this is all covered and certified by the FAA in the first place. This would not be occurring if it were illegal and the wrong airplane for the wrong runway. Those statements are untrue and simply sensational, biased, and malicious. And while it wasn't the most exciting presentation in the world, no doubt, I hope that this was informative and helpful in reassuring your viewpoint that we're not operating outside the margins of safety. Thanks, and have a good day.